Good morning students, welcome to our next lecture of minimum spanning tree. In today's lecture we will study the second algorithm of minimum spanning tree. In last lecture we have studied about the Kruskal's algorithm and our today's topic is Prim's algorithm. In Prim's algorithm we start with single edge of the graph, okay, with that single edge, and then we keep on adding the edges and then finally we get the minimum cost tree, that is minimum spanning tree. Single edge means we will join our skeleton graph starting with the single edge and then according to the minimum weights of the edges given of the original spanning tree, we will add the edges with the minimum weight. So we will understand Prim's algorithm with this example. This is a main spanning tree graph or main spanning graph. Here we have 4 nodes A, B, C and D. From node A to B we have 2 edges, one with the weight 2 and the other one with the weight 3. Similarly, from nodes B to C we have 2 edges, one with weight 4 and the other one is 6. From node C to D again we have 2 edges, one with weight 2 and other with weight 4. And from node D to A we have only one edge and its weight is 9. And the node B is connected to D with an edge and its weight is 7. So let's start solving this spanning tree to get a minimum spanning tree of this original spanning tree. For creating a minimum spanning tree from this original spanning tree, what we will do, our first step will be, we will create an edge list. This is our edge list and this edge list has been created from this main spanning tree. This edge list contains the edges and their corresponding weights. Edges means edges are the nodes which we have taken and the nodes which are being connected by the edge, and the weight corresponds to the weight given above the edges. So here edge AB has weight 2 and weight 3. Similarly, next comes AD, the edge AD which is connecting nodes A and D and its weight is 9. Next edge which is connecting nodes B and C have 2 weight 4 and 6 respectively. Then comes the next edge which is connecting node B to D and it contains the weight 7. And after that we have 2 edges connecting our nodes C to D with first weight as 4 and second weight as 2. So what we will do for solving this spanning tree, that means converting this main spanning tree into minimum spanning tree using Prim's algorithm, this was our first step of creating edge list with their corresponding weights. Now the second step comes. In second step what we will do, we will make a skeleton of our original spanning tree. Skeleton means, I have also told you in our previous lecture, skeleton is the graph which contains only nodes, not the edges. So our second step is we will make a skeleton of our original spanning tree, and after making the skeleton what we will do, we will join the edges one by one according to their minimum weights. Okay, so for joining the nodes A to B, we will see the minimum weight. Here we have edge which is connecting A to B. We have 2 options. So from the 2 options what we will consider? We will consider the one which has the minimum weight. So minimum weight we have is 2. So we will connect node A to B through the edge with weight 2. Now next point comes here is that which node, which edge we should use to connect our rest of the nodes so that we get a minimum spanning tree. So for connecting the other nodes we have two options. Either we connect node A to D or we can connect node B to C or B to D. So let's see all the options. For connecting node A to D node gives us the weight 9. Second option is for connecting nodes B to C. B to C gives us weight 4 and 6 respectively. So what we will do, and the other option is node for connecting the nodes B to D. For connecting the nodes B to D gives us weight 7. So what we will do, we will choose the option which gives us the minimum weight of the edge. Minimum weight means we will choose that edge that contains the minimum weight so that we can get the minimum spanning tree. So we will consider the edge which is connecting the node B to C with weight 4. So we have, among the four options, we have the minimum weight as 4 and we will consider it to get the minimum spanning tree. So what we will do, we will join the edge from node B to C and the weight of this edge is 4. After joining, after inserting the edge from edge list to the minimum spanning tree, we will delete that edge from the edge list. Okay, so till now we have used two edges for connecting our nodes. Now the next edge that we can connect to get a minimum spanning tree gives us three options. First option is connecting the node A to D. A to D again gives us weight 9. Second one is C to D. For connecting node C to D we have two options, 4 with weight 4 and weight 2. And the third option is for connecting the node B to D. For connecting the node B to D gives us the weight 7. So from the given options we have to select the node which gives us the minimum weight. So we have first option as A to D which gives us weight 9. Second option we have C to D which gives us weight 4 and 2 respectively, and the third option gives us A to D which gives us 9. So from these available options what we will do, we will select the node with the minimum weight. Now the minimum weight we are getting is for node, for the edge which is connecting the node C to D with weight 2. So what we will do, we will connect our node C to D and the weight of this edge is 2. So now we have got a minimum spanning tree. No further connections can be done in this tree. So this is our minimum spanning tree. We denote this minimum spanning tree with capital MST, and now we will calculate the cost of this minimum spanning tree. The cost of this minimum spanning tree is 2, weight 2 of the edge which is connecting node A and B, plus weight 4 which is connecting the nodes B and C, plus the third edge which is connecting the nodes C to D with weight 2, and it gives us the result 8. So this is the minimum cost of the original spanning tree. We cannot get the cost less than 8 by joining any of these nodes through the given edges less than 8. So 8 is the minimum cost of this original spanning tree. Okay. Less than 8 is not possible in any case for getting the minimum spanning tree. So this was the procedure of solving Prim's algorithm. The main thing that we should always keep in mind while solving the Prim's algorithm is that we cannot take any edge that will make a loop. That means while talking about the node A and B, we have two options, one with weight 2 and other with weight 3. So we have taken the edge with minimum weight, that is 2. Now next comes the again edge which is connecting A to B with 3. Now if we connect the node A to B again with weight 3, what it will do? It will make a cycle, and for connecting the nodes, for making a minimum spanning trees, the main thing that we should always keep in mind is that our minimum spanning tree should not contain a cycle. That is, cycles and loops are not allowed in minimum spanning tree. So this thing should always be kept in mind. Okay. This was our Prim's algorithm. Hope you all have understood it. Thank you so much.